Now, before solving the problems, I want to give a quick review about the ellipse whose center is at the origin. So we have two types of ellipse in this case. It might be horizontal or a vertical type. And for the horizontal type, you see the x-intercept here is bigger than the y-intercept. As you see here, this is important. You have to be careful about this. And here we have another thing, which point is we call it the focus. This is focus, and this point, the number here is C. And the focus, we call it C0 is the focus here, and minus C0 is the focus. I mean, we have two focuses, we call it foci. We have two foci. And here the big length here, this one is called the major axis, and this is called the minor axis here. So this is minor axis. And the vertices, the endpoints of the major axis will be negative A and A0, negative A0 and A0. So these are the vertices. And these are the important things you have to know about an ellipse of this form. So this C is not arbitrary, by the way. There's a relation between A, B, and C here. A is the x-intercept, you know, and Y, B is the y-intercept. And the relation between A, B, C is as long as so A is bigger than B, you know, in our case, so C squared will be equal to A squared minus B squared equal to C squared. And so this is the relation between A, B, C. So equation of this type of ellipse will be x squared over a squared. So this is the x-intercept here of the ellipse. This is y, one of the y-intercepts of the ellipse here. So you're taking the squares here. A and B are the y and x-intercepts, and you're taking the squares and putting them under x squared and y squared, and you get the equation. Now in this part we have the same issue. Now the ellipse looks like this one because B is bigger than A, so we have kind of vertical. So this is important. It might be a vertical shaped ellipse, and we have the endpoint of the major axis. We call it the major axis again. Major axis means like the long one all the time. The major is the long one. This is the short one, and it's the same thing here. Same here also. Same in the other. Now B is we call it these points, vertex, the endpoints of the major axis. So they will be on the y-axis now, 0B and 0 minus B. These are the two vertices. And we have two foci, 0, C, and minus. These are the foci here, C and minus C points. And here the endpoints of minor axis are the x-intercepts A and minus A. Now, is there a relation between A and B and C? Yes, of course, there's a relation. They're not arbitrary. I mean, C is not arbitrary for sure. Here, since B is bigger than A, so C squared is equal to B squared minus A squared. And the equation will be, again, x over the x-intercept squared plus y squared over the y-intercept. So if you know A and B, you can directly write the equation. So let's do some exercises. And let's see. Which of the following represents an ellipse? The equation of an ellipse. So the equation of an ellipse has to be this way, like a squared plus y squared b squared equal to 1. Here we don't have to write squares. Indeed, these can be like any positive number. Any positive number is fine, and any positive number is here fine. Here, for example, okay. So we will try to change them to ellipse equation. So this x squared plus y squared equal to 400. So when we divide by 400, we will get this one. So this one looks like an ellipse. But yeah, this is an ellipse equation. But the problem here is we don't want them to be equal, because if this is equal, this makes a circle here. So circle is kind of an ellipse with the same, numbers here. So this is a circle. This is not ellipse. Um, Now we can check this one. Divide both sides with 400. So this will be, okay, if you do the division here, it will be like 16 here, and this will be, if you make the division, what happens? Okay, I think it's 25, so it will be y squared equal to divided by 25. So this makes an ellipse. And for sure, these are not ellipse because there's minus here. Even you would divide with 400. This is not an ellipse here. We have x squared over 400 minus y squared over 100. I mean 400 to 1. This is not ellipse. The ellipse has always x squared over a positive number plus y squared over a positive number equal to 1. And we don't want it to be 0. Otherwise, I mean, it will be just a circle, not an ellipse. So this is B. Now, the foci of the ellipse here, I want to remind you what is foci. When we say foci, this is the plural form of focus. So we mean foci means the two focus. The foci of the ellipse defined by are, okay, let's see, x squared, 5x squared plus 6y squared equal to 30. And always try to make it equal to 1. So this will be x squared over 6 plus y squared over 5 is equal to 1. Okay, now the foci is, it might be 0 c. The foci are like 0 plus c or 0 plus minus c. And here our a squared is this. Here our b squared is this. Now, what's the relation between c squared? So it will be the big one here, which one is bigger? So b squared is bigger than a squared. So you write here b squared bigger than minus a squared. So c squared will be 6 minus 5. So it will be c will be plus minus 1. Now it comes to this question here, which one? Like we know c will be plus or minus 1. Okay. So definitely it will be this one or this one. Okay, which one? Now here the important thing is you have to pay attention to which one is bigger here. So this one is bigger. So the x-intercept is bigger than y-intercept. So it means that the focus means, what does this mean? It means we have a shape like this, okay? So if it is, if this is the case, then where is the focus? It has to be on the x-axis. So C has to be here -1 and 1 here. So what is the focus here? The focus 1 and focus 2 has to be, their coordinates are -1, 0, and 1, 0. So you say foci are plus -1, 0. So it has to be the first one. So what does this mean? After you find the C, you will check which one is bigger, the number under X or the number under Y. So if this is the number under X is bigger, it means the focus will be on the X-axis. Let's find the equation in standard form of the ellipse. with center at the origin and satisfying the given condition. Now the foci is 0, plus, minus 3, and the x-intercepts are plus, minus 1. For the equation, okay, all the time we need this x squared over a squared plus y squared over b squared equal to 1. And in this case, we have to find this a and find this one. A is all the time the x-intercepts, one of the x-intercepts, and b is the y-intercepts, one of the y-intercepts. Because since you are taking the square, so there will be plus and minus issue, but square will take care of it. So here, let's try to find, okay, a is already given here, so a is plus 1, minus 1, so it says a is 1, you can take the foci. Okay, let's try to understand this. I would say first put the foci plus 3 here and minus 3, these are the foci. So if you have the foci, you can directly say, hey, the ellipse will be this shape. So the major axis always, the foci always on the major axis in the long part. So here, x-intercept will be 1 and y-intercept will be 1. And to get the, remember it, this is C. In our notation, this is A, and this is B here. To write the equation, we need B. What is B? What's the relation between A, B, C? So we know C squared is B squared minus A squared. Why? Here B is bigger than A because of the foci here. The foci is on the y-axis, so the ellipse is longer on the y-axis. So C squared is equal to, okay, what is C? C is 3. 3 squared is equal to B squared, we don't know. And A squared, A is 1. B squared has to be 8. So, okay, we can find the one of the y-intercepts, like plus minus square root of 8, so we can take one of them. But when we put these values, no need to find B indeed, like we need only B squared and A squared. So then we can put them here. A is 1, so B, like A squared is 1, and here from here, and B squared is 8. So this will be the equation of it. Now determine the foci and the vertices of the ellipse given with the given equation and graph the equation. Okay, always better for me. The plotting will be easy. The graphing is always easy. So it's a squared is equal to b, and I mean a squared is equal to 9, b squared is equal to 4. You can find here a is 3 and b is 2, and you can directly say this is 3. So this is 2. Sorry, this is 3. You know, x under x we have 3. X-intercept is 3, and the y-intercept is 2. And then you can make this ellipse. And the vertices are definitely 3 and minus 3. The vertices are plus minus 3, 0. And the foci has to be in the same axis as the vertices. Like, well, let's say 2. If this is A, if this is B, then this has to be C. And what's the relation between C squared and AB squared? It will be A squared minus B squared this time, because this is 9 minus 4. This will be equal to 5 squared 5. And here the foci are, you can say foci are plus minus squared 5, 0. So they will be on the same axis as the vertices. Okay, I think no need to erase this part. As a shortcut, you can directly say C squared is equal to, without going into A squared or B squared, you can directly say it's 9 minus 4. This is also a shortcut, I mean. And here, let's look at this one first. Let's try to make it into the standard form by dividing both sides with 4. So you'll get 1 here, I guess. Yeah, 1. and this one is y squared over 4, which is equal to 1. And then, so I did this, okay. A squared is 1 and b squared is 4. And what is c squared? C squared is like 4 minus 1 automatically. This is 3. And then c will be equal to square root 3. And then we can put everything in here, plot them. B is 4 and b is 2. B is 2. And then a is 1 here, from here. A is 1. And then the foci. Now, where is the foci? So it will be on the major axis, so it will be square root 3, and then here minus square root 3. So these are the foci, will be 0 square root 3, and okay, there's a focus 1, let's say, or when we say foci, it means focuses, by the way. It's, irregular plural. So the foci will be square root 0 square root 3, 0 minus square root 3, and the vertices will be, vertices will be the endpoints of the major axis, and the major axis is this one here, the long one. So the vertices will be 0, 2, and 0 minus 2. Now let's look at the last one. So it will take some space to do it. So for this reason, I want to erase all of the. Okay, now first write this one in standard form. A good question will be, okay, how to do it. This is already in standard form. What I mean here is you can write this one as 49 over 16. You can write this one as y squared over 81 over 25. Now we get a squared. A squared is equal to 49 over 4, 16. And b squared here will be 81 over 25. So b will be here 9 over 5. And a will be here 7 over 4. Which one is bigger? This is about 0. Okay, this will be about 0.18. So b is bigger than a. You can check this one, like 9 over 5. Is it bigger than 7 over 4? Because 4 times 9, 36, and like 7 times 36. Okay, this is 35. So this is bigger than this one. So here, b is bigger than a. So c squared will be equal to, the big one is, we know 9 over 5, so it has to be 81 over 25 minus 49 over 16. Now, if you do this calculation, if I am not wrong, it has to be 71. So when you do this calculation, we'll end up with C will be square root of 71 divided by square root of this thing. This will be 100. Okay, in this case, now we've got A, B, C. We can make the graph of it. For the graph, only A and B is enough, but we want to show the vertices and the vertex here, the foci. Okay, which one is bigger? The value under y is bigger, so it has to be on the y-axis. So 9 over 5 is here. 7 over 5, 7 over 4 is here. Something like this, okay. Now here, 9 over 5 is bigger than 7 over 4, but and where the foci, so foci was on the long side. This is the long side here. So this is the major axis. This is the long side. So where is C? C is square root 71 over 100, and this will be square root minus square root 71 over 100. So now the foci will be 0 square root plus minus square root 71 over 100, and then the vertices will be, these points are the vertices, the endpoints of the major axis, that they have to be 0 plus minus 9 over 4, 5. So it's done. Find the equation in standard form of the ellipse with center at the origin, satisfy the given conditions. Like we want to find the equation. Now the vertex is at 0, negative 2, 0, and the focus is minus 0, minus what, 0. So this is your C here. Definitely this is C. C is 1, you can say, or anyway. So C is one of the C's. Okay, minus C is minus 1. If you want to go, okay, we can go this way. And here, it's better you make the picture of it, minus 1, 0. Where is it? It's minus 1, 0 is here. And the vertex is minus 2, 0. And then if this is the vertex, this is the focus, so we have to have such thing. And what can we say about, okay, about the equation? So for the equation, we need A and B here. And look, one of the focuses F as negative 1, so it has to be here 1, the other focus. So you can say C is equal to 1, definitely. And what is A? If A is standing on the other side, on the other vertex here, so we have two vertices. Let's say F1 and V1 and V2. So A should be equal to, if this is minus 2, A should be equal to 2 because it's symmetric. So here, since the major axis, the focus is on the x-axis, this is the long part, this is the major axis, so A is bigger than B. Now we can say here, we can set up the relation between A, B, and C. C squared is equal to, we know, it's A squared minus B squared. So C squared is equal to, which is 1. 1 squared is 1. And A is like 2 squared, so this will be B squared. And B squared turns out to be 3 here. So we have A squared, we have B squared. So it will be x squared over A squared, which is 2 squared, and plus y squared over B squared, which is 3. Then this will be 1 squared over 4 plus y squared over 3 is equal to 1. Now the vertex is at 0, 2, and the focus is at 0, minus 1. Okay, it's better you sketch the graph of it. So the vertex is 0, 2, which is 0, 2 is here. And this is one of the vertices, and the focus at 0, minus 1, so which is minus 1 is here. And this is the center, we know the center is at the origin. So if this is the vertex here, it's one of the vertices. And the other vertex has to be at minus 2, vertex 2. And the focus is here, and the other focus has to be at 1 then. So by giving these two, it's giving all the information about the ellipse. Now we have such thing. Okay. Now what we need here is the a value here. So this is the question here. What is a? And b is obviously 2 from here. Like this is b is 2. And do we know the focus here? The focus is the C value. C value is obviously this one here, and then this is minus C. So the relation between C and A and B is which one? 2 squared. So it will be B squared minus B squared minus A squared, because here B is definitely bigger than A, because we have the focus and the vertex and on the major axis, and the long axis. And long axis is y-axis, so B is bigger than A. So C squared is equal to, no, C is 1 squared, which is 1. B squared is 2 squared, and then A squared is, okay, we don't know A squared, so A squared will be equal to 4 minus 1, which is 3. And now we can write the equation here. The equation will be x squared over a squared plus y squared over b squared plus 1 is equal to 1. So x squared over a squared plus y squared over b squared is equal to 1. So this will be, a squared will be 3, and b squared will be 2. So sorry, 4. So we'll have this equation. Yeah, we are now in this in the other okay, in the other question we have a different case. I think it was this, right? Now in the other question, let's read the question first. The minor axis of length is square root 13. So minor axis. So let's talk. Okay, let's see. Focus. Where is the focus? The focus is minus 5, 0, and minus 5, 0 is here. If this is the focus, then the ellipse should be like this, you know, the long side here. And the minor axis length is square root 13, so it has to be this one, square root 13. Now what you can say here is this one here has to be square root 13 over 2, and this has to be minus square root 13 over 2, right? Because this here, the square root 13 is the whole length of the minor axis. And then the focus is minus 5, so you can say the other focus is 5, 0. And what can you say here? Like, I got B, I don't know A. This is a little. Okay, now it's better. Now this is A, we don't know A, but to write the equation we need A squared and B squared. A is, and what's the relation between A and B and C? C squared is equal to A squared minus B squared, right? Because A is bigger than B here, right? Because the focus is on the major axis in the long part, so A should be bigger than B. So C is, we know, 5 squared, and this is A squared. A is, we don't know A. And B squared should be 13 over 4. And, okay, if we do this calculation here, A has to be, A squared has to be square root, no, A squared should be 113 over 4. And we know B is, B squared is 13 over 4, so we can write the equation this way. And y squared over 13 over 4 is equal to 1. I mean, you can flip them and you can do this job. Okay, I don't want, okay, let's do it like 4x squared over 113 plus 4y squared over 13 is equal to. So this is the form, this is the equation for this. ellipse. Now the foci of the ellipse defined by r, okay, by 5x squared plus 6y squared equal to 30r, what? Now, okay, let's write it in standard form. So how can we do it? You divide both sides 30 will be x squared over 6 and y squared over 5 equal to 1. Now, this is a squared, this is b squared, and then c squared will be equal to the big one, which is here a squared. So a is bigger than 5, so you have to say this is 6 minus 5 is equal to 1. So c and minus c is 1 and minus 1. Okay, so minus. So these are the focus. So we will have this one over this one, not those for sure. Because the foci will be here. What the foci will be, since the number here 6 bigger than 5 here. This when we look at this part, the denominator under x is bigger than. Okay, so we say the foci is. Okay, I will write this one. The denominator under x squared is bigger than the denominator under y squared. So foci are on the x-axis. So this is the idea. So you have 6 bigger than 5. So the foci has to be on the x-axis. Foci are on the x-axis. So it means it will be c0. So it will be c0 and minus c0, and which is, if you use this one, it will be b. So it will be b only. So because this is foci are on the y-axis. Find the standard form of the equation of an ellipse with vertices at 0 plus minus 5 and the foci at 0 plus minus 4. Okay, it's better we draw it. We sketch the graph. This is the vertices are 0 plus 5 and minus 5, so it has to be on the y-axis. It's plus 5 here and minus 5. So you plot these points here, and it means if the vertices are here, these are the vertices, vertex 1, let's say vertex 2, and this has to be a little a vertical ellipse. Now the foci has to, it says the foci is like at 4 and minus 4. So the foci, and they have to be in the same axis as the vertices. Okay, now here we need to write the equation. We need x squared over a squared, y squared over b squared is equal to 1. And then a has to be here. Okay, we don't know a. This is the problem, and we know b. B is 5. And what? So c is, we know c is 4. So what is the relation between c and a and b? So which one? Is it this one? No, because a is less than b. So this is a vertical asymptote, a vertical ellipse. So b is bigger than a. So it has to be b squared minus a squared. So it will be 4 squared is equal to b squared is 5 squared, and this is minus a squared. And after you do this calculation, you will end up with this one is 9. Now we know a squared equal to 9. That has to be 9 plus y squared is under y squared we have b squared, which is 5 squared. So this is equal to 1. So it has to be 9 plus 25. 9 x over x squared over 9. Okay, I think there's a mistake here. This has to be 9. So it will be b. Now the point squared 50 lies on the ellipse with foci at plus minus 0. Find the equation of this ellipse. Okay, let's try to draw this one. Plus 1, minus 1, the foci here, plus 1 and minus 1. Okay, automatically these are the foci here. Automatically you can say it will be something like this because foci are on the major axis. Major axis is the long one. The squared 50 lies on the ellipse, so where is it? It has to be, if it's on the x-axis, right? So it has to be then squared 50 is in here. It's the only one positive x value on the x-axis on the graph of the graph. Now, I take one. Okay, more or less, it's fine. Squared 50. Then here we have x squared over a squared plus y squared over b squared thing. So what is A? A is squared 5 for sure. And B, we don't know. C, this is the focus, you know, focus 1, focus 2. So the C has to be here 1. So what's the relation between A, B, and C? So here A is bigger than B, right? Because here the focus is on the major axis and this is bigger. So A is bigger than B. So we say C squared is equal to the big one, which is A here. And then C squared is equal to C is what? C is 1. C is 1. This is A squared is squared 5 squared. B squared, so B squared is equal to, okay, B squared is equal to now 4. Now we can put everything and then find the equation. That's A squared is 5 and B squared is 4. So from here, okay, this is the equation for it. But okay, how can we? I mean, we don't see exactly the same equation among the choices. But what we do here is to multiply both with the common denominator, which is 20. So multiply both sides with 20, and you get x squared plus 5y squared is equal to 20. So it has to be B. Find the equation of an ellipse in the form, okay, with major axis in standard form. It means like in the standard form. With major axis along the x-axis. This is an important information, so it says the long side is on the x-axis. And the major x is length 4, and then minor x is length 2. Okay, let's try to put this. Major axis along the x-axis. Okay, this is the major axis. And then major axis has length 4, so this is the length here will be 4. So it has to be 2 here and minus 2 here. When you divide it by 2, you know, you split it into half. Okay. Now then, the minor length is the length of the minor x is 2. So you can say since it's symmetric, it will be 1 minus 1. Now it's easy to write. Okay, it's easy to write the equation. Now for x we have 2 squared you write here, and then for y we have 1 squared y-intercept, so it will be 1. So it will be x squared over 4 plus y squared equal to 1. Which of the following graphs represents the ellipse with the equation 9x squared plus y squared equals to 36? In order to do this one, you divide this with 36, and it will be equal to 1, and you end up with x squared over uh, 4, and this will be y squared over 36. Now this is a squared and this is b squared, and you can say a should be equal to 2 and b should be equal to 6. And what is a? A is here. A is on the x-axis, it's 2, and b is on the y-axis, it's 6. So it has to be b. Okay, I want to give a warning about the table on the slides is using a and b in different ways. Be careful. So I'm using a and b here the same. Okay, a here and b here. In the slides on the table, I mean there's a table in the table. It's using a b here for the long part, and in the other one it says like b a. Be careful about this. Okay. But here I'm using a b both for both. Okay, for both cases, and I think is it okay. Now the last one. Here, okay, this is very straightforward. Here's 1 here and here's 2, and we want to find the ellipse, so you can say x squared over the x-intercept squared. What is the x-intercept? Is doing 1 squared. Sorry, y. Sorry, this is 2 squared, and y squared over y-intercept is 1. Will be 1 squared. It is equal to 1, so it will be x squared over 4 plus y squared over 1 is equal to 1. And okay, how can you? Okay, this is not among the choices here, so we have to do some manipulation here. Just multiply with 4, so you'll get this one. So equal